A free alpha particle and a free proton, which are separated by a distance of 10 power minus 10 meter, are released. The kinetic energy alpha particle, when at infinite separation, that means when they reach to infinity, the kinetic energy alpha particle is a question. So it is given that there is a free alpha particle and there is a proton, and a separation may be something r. So initially they are at a distance of 10 power minus 10 meter and they released, and we know that they move to infinity in the sense because the repulsion they are moving away. At infinity, the kinetic energy alpha is asked. So how to find out this? So when you calculate this two particle, they are at a distance of minus 10 meter, they have some energy called a potential energy. Since the energy conserved, this potential energy should be available for those two particles as a kinetic at infinity. Therefore, potential energy of these two particles at a distance of minus 10 should be equivalent to kinetic energy alpha and kinetic energy of proton at infinity. Now, when you write a total energy, what is the total energy? We know the total energy, it is 1 by 4 pi epsilon naught. It's a Q1, Q2 divided by R. That's equivalent to kinetic energy alpha, kinetic energy proton. So therefore, it is 9 into 10 power 9 into Q1, that's the charge of alpha, it's a 2 into 1.6 10 power minus 19. Charge of proton 1.6 into 10 power minus 19, whole thing divided by 10 power minus 10. And that is equivalent to kinetic energy of alpha plus that of proton at infinity. And if you simplify this, you'll get a value 46 into 10 power minus 19, that is kinetic energy alpha plus that of the proton. I'll name this equation as 1. So total energy of alpha and proton we got. Now how to find the energy of the alpha? That is what I asked. For this, we know they initial at rest at a distance of minus 10. They must have some momentum, and when they reach once again they have a momentum. Since the initial momentum 0, final momentum should be equal to 0. So they based on that momentum carried by that, we can write the kinetic energies. How to write? So we know momentum of alpha therefore is equal to momentum of proton, conservation momentum. Let it be value p. Therefore kinetic energy of proton can be written as, it is a p square divided by 2m, where m is a mass of proton. Using that, if I write a kinetic energy alpha, it is a p square divided by 2 into 4m, because mass of proton is 4 times. Mass of alpha is 4 times that of proton. And if you consider this, p square by 2m is a common. I'll write this as E, and therefore this is E by 4. Hence, we got kinetic energy of proton as E, alpha is E by 4. Therefore, if I substitute in the equation number 1, therefore it is E plus E by 4, that is equivalent to 46 10 power minus 19. And if we simplify, 5 into E divided by 4 is equal to 46 10 power minus 19. Therefore E is equal to 46 into 4 divided by 5 into 10 power minus 19. So therefore E is equal to, you'll get 36 10 power minus 19. So E is the energy of proton. This is the energy of the proton. Therefore energy of the alpha, it's the E by 4, that is 36 into 10 power minus 19 divided by 4. It's around 9 10 power minus 19, so many joule, and that is given as option D.